Hi, and welcome to Failurology, a podcast about engineering failures. I'm your host, Nicole, and I'm from Calgary, Alberta. I can't believe it's already 2021. It feels like forever since COVID changed our lives back in March here in Canada. At the same time, it seems like the older I get, the faster time moves. While time itself is a constant, our perception of time is relative, which in itself is a fascinating phenomenon. At the beginning of every year, I set goals for things I hope to achieve. I guess you could call them New Year's resolutions, although resolutions are more of a decision to do or not do something, whereas goals are an object of desired result. Although this year, travel will probably stay close to home until I'm able to get vaccinated. I also have fitness goals, a number of books I hope to read, savings goals. I even have some goals for this podcast. Do you have any goals or resolutions for 2021? What are they? I'd love to know. This week's failure is the Malahide Viaduct, north of Dublin, Ireland. The failure blocked the only train route between Dublin and Belfast for 3 months in 2009. Water is a beauty, but it can also be a real pain. I've seen water destroy bridges, degrade pipe, and in episode 2 I talked about the impact of water on the city of New Orleans during Hurricane Katrina. And similar to that episode, I came into researching the Malahide Viaduct thinking I knew what I was going to find, but what I uncovered was so much more interesting. But before I get into that, the news. This week in engineering news, the UK's first electric-only charging station opened for business in early December. The charging station, located in Braintree, Essex, has 36 electric vehicle chargers delivering up to 350 kilowatts of power. The chargers can provide over 300 kilometers of range in 20 minutes for a cost of roughly €10 or $15 Canadian. The chargers are powered by solar panels on the station's roof and a network of hybrid and solar wind farms. There is also a 6 megawatt-hour battery at the station to balance power supply. Several countries, cities, and territories have implemented or proposed bans to the sale or registration of new gas or diesel vehicles. The UK joined this list in 2020 with a proposal to ban the sale of new combustion engine vehicles by 2030. Canada's goal is to ban the sale of combustion engine vehicles by 2040, with British Columbia banning by 2025, Vancouver by 2030, and Quebec by 2035. Alberta is a bit behind the 8 ball on renewable energy as of late. We have plenty of solar and wind farms, but we also have a government and several citizens obsessed with reinvigorating the oil and gas industry. But I personally think that it's a dying industry and we should diversify into other industries before we get left behind. But that's just me. If you want to read more on the charging station, check out the website page, link in show notes for this episode. I'll also include a link to the Wikipedia page with a list of phase out of fossil fuel vehicles. Now on to this week's engineering failure. The Malahide Viaduct collapsed in Ireland. On Friday, August 21st, 2009, at around 6:30 p.m., Pier 4 and 20 meters of post-tension concrete beams between Piers 4 and 5 of the Malahide Viaduct collapsed into the water. Irish Rail is a network of over 1,900 kilometers of railway with 7 routes radiating from 2 main terminals in Dublin, Connolly and Euston Station. I visited Ireland in 2019 and Irish Rail was a great way to travel around the country. We took the train from Dublin to Galway and then down to Cork and Cove and back up to Dublin. It was a really easy and rather cost-effective way to travel. The Canadian equivalent, Via Rail, is not as accessible. It doesn't even come to Calgary. And there's no train between Calgary and Edmonton or Calgary and Vancouver. We either have car, bus, or air travel for options. I would much rather travel by train. I would probably travel to these cities more if train was available. The Irish Rail network contains 780 viaducts. Viaduct is derived from the Latin word via, meaning road, and ducere, meaning to lead. A viaduct is a type of bridge that consists of a series of arches, piers, or columns supporting a long elevated railway or road. They're usually used to connect two areas of similar elevation across a river valley or other low-lying feature. The Malahide Viaduct, also referred to as the Broadmeadow Viaduct, is located about 15 kilometers north of downtown Dublin, north of a small settlement called Malahide. If you've ever ridden Irish Rail between Dublin and Belfast, you've crossed this viaduct, as it's the sole train route between the two. 82 passenger trains and 6 freight trains pass over the viaduct every weekday. The track of the viaduct is a double-track, continuous weld rail on concrete sleepers. The maximum speed over the viaduct is 145 kilometers per hour, and due to tight clearances, there are permanent speed restrictions between Malahide Station and the viaduct. The viaduct is 180 meters long, but it forms part of a longer causeway across the Broadmeadow estuary. As we know from the levee failures in episode 2, an estuary is where a stream or river meets the sea. The water is brackish, meaning a mix of fresh and salt water. The total crossing is about 1,200 meters in length. The first structure to cross the estuary was built in 1844 by the Dublin and Drogheda Railway. It was a 175-meter timber structure with 10 timber piles placed 15.85 meters apart. The original structure was replaced in 1860 with wrought iron, lattice girder beams, and masonry piers. Due to sea air, frequency of use, and the weight of the locomotives, a more robust structure was required. The current structure has been in place since 1968 and is made up of pre-stressed concrete spans and 11 stone piers with gravel ballasts. As the tides rise and fall, water travels through the viaduct, resulting in scouring. Scouring erosion is the removal of sediment such as sand or gravel from around bridge piers. It's caused by fast-moving water that travels around the pier and scours or scoops out sediment on the opposite side of the pier. It's estimated that 60% of bridge failures are caused by scouring. To overcome this problem, a stone weir was constructed from 90,000 tons of stone along the length of the viaduct in 1846 to protect the piers from scour and maintain a constant level of water in the estuary. This meant that the piers were not founded on bedrock. They sit on top of the weir. The integrity of the piers relies on the integrity of the weir. This is very important. Stones had to be replaced regularly to maintain the weir's integrity. The bridge design has easily removable handrails to allow stone discharge along the weir. Between 2,000 and 6,000 tons of stone were regularly discharged from as early as 1922, with the last documented time before the 2009 collapse being in 1996. There is evidence of complaints from locals in 1957, 72, 92, 95, 96, and 97 that discharging stones impacted the water level in the estuary and impacted their livelihoods or recreation. This may have contributed to a stop in stone discharge after 96, although this is speculation on my part. The construction of the viaduct allowed for even flow through all 12 spans. This is important so that one area does not wear or erode faster than others. In addition, the stone weir impacted velocity through the viaduct. During ebb tide, which occurs between high and low tide, where water flows back to the sea, the step up to the weir from the bottom of the estuary reduced flow through the viaduct, causing a drop in pressure and an increase in velocity and scour potential. During flood tide, which occurs between low and high tide, where the water flows into the estuary, the weir acts as a step down, increasing flow through the viaduct, increasing pressure, and decreasing water flow. To recap, we have ebb tide, water flowing out to sea, which has an increase in velocity, and flood tide, water flowing into the estuary, which has a decrease in velocity. When tide switches from ebb tide to flood tide, it does so smoothly, but the change from flood tide to ebb tide, when flow changes from into the estuary to out to sea, it causes a vigorous turbulent mixing action which creates scour erosion. As the erosion occurred over several years, the width of the weir expanded as stone was pushed outwards with each tidal change. This also removes stone from around the piers, exposing them to erosion and risking their structural integrity. In 1967 and 1968, in an attempt to stabilize and minimize erosion of the weir crest was grouted to form a grout rock armor. It proved successful after storms in 1969. However, over time, it too started to erode. On Friday, August 29, 2009, around 6:30 p.m., Pier 4 and 20 meters of post-tension concrete beams between Piers 4 and 5 collapsed into the water. Pier 4 was the fourth pier from the north end of the viaduct. At 6:20, the 8-car 550 train from Perth to Dundalk passed over the viaduct in the down direction, north towards Belfast. At 6:22, the 4-car 607 train from Balbriggan to Perth approached the viaduct in the up direction towards Dublin and observed water splashing up over the viaduct as the 8-car Perth to Dundalk train had passed over it. As the 4-car 607 train passed over the viaduct, the driver witnessed a section beginning to collapse. Luckily, the 4-car train made it safely across, and the driver raised the alarm when he arrived in Malahide. The signalman set all signals to danger, ensuring no trains crossed the viaduct. The driver of the 4-car train made an unscheduled stop at Malahide station and detrained all passengers. He walked back along the track to the viaduct and observed that Pier 4 had collapsed and the post-tension concrete beams of span 4 and 5 had also collapsed. The weather conditions at the time of the accident were dry with good visibility. The accident occurred close to the time of the second low tide of the day. The morning low tide that day was the lowest tide for that month, and the tidal range was also one of the largest for the month of August. A canoeist on the estuary noted that some stones at the base of Pier 4 had washed away. This was 4 days before the collapse. An assistant engineer with Irish Rail investigated the next day, 3 days before the collapse, and noted missing or cracked stones but no structural defects. From what I've read, the assistant engineer was not familiar with the structural or tidal conditions of the estuary. The area in question was not within their division. They also incorrectly assumed that the piers were on bedrock, rather than sitting on the weir. This was a missed opportunity to correct the bridge before failure and indicates poor training and record keeping within the Irish Rail maintenance system. A passenger traveling over the viaduct at 9:35 a.m. and again at 5:55 p.m. on the day of the collapse noticed a 3-meter diameter whirlpool on the west side of the viaduct. Over time, due to a lack of maintenance to mitigate erosion, a channel had formed between piers 4 and 5. The water was no longer evenly distributed between all 12 spans. For days, months, or maybe even years leading up to the collapse, during the end of the ebb tide cycle, with water flowing out to sea, the majority of water flowed between piers 4 and 5, increasing erosion through the section. The erosion around Pier 4 ultimately led to a phenomenon called piping, which is a subsurface formation of a continuous pipe-like tunnel, meaning that the water eroded the material underneath Pier 4 until it eventually gave way. But how could this have happened? Well, following the collapse, the Railway Accident Investigation Unit investigated the failure and shed light on several issues. The scope of their investigation is as follows. Establish the sequence of events that led to the collapse. Establish the immediate cause, contributing factors, and underlying causes that led to the failure. Review the management of inspections and maintenance of the viaduct. Review historical documents related to the viaduct. And review the role of the Railway Safety Commission in relation to enforcing safety recommendations. 3D and 2D models of the viaduct were created, as well as mathematical and hybrid models to simulate hydraulic mechanisms involved in the collapse. A post-accident survey found an asymmetrical scour hole under Pier 4 that was roughly 4 meters deeper than the base of Piers 3 and 5. The live load or dynamic load of trains passing over the viaduct is believed to be a contributing factor in the undermining of the Pier 4 collapse. The concrete beams were removed from the viaduct and tested at an off-site facility, but the beams passed the required loading for the structure and were not found to have contributed to the failure. Track inspections, or lack thereof, significantly played a role in the failure. The tracks are regularly inspected by patrol gangers. The viaduct was a section of track from the 7.25 mile post to the 9.5 mile post in Division 1, and the 9.5 mile post to the 13.75 mile post in Division 5. This meant the patrol ganger reported to 2 separate divisions and 2 separate permanent way inspectors, requiring 2 separate logbooks. The last patrol of the Malahide Viaduct was carried out on August 10th, which noted no faults in relation to structure. There should have been a more recent patrol, but the patrol ganger was on vacation and no one was assigned to relieve his duties, likely because each division thought the other was looking after it. Patrolling standards stated that the underneath of bridges be checked at least once a year for scour, but there is no record of any scour check of the viaduct by a patrol ganger. Identification of scour would have required access under the bridge as well as specialized training, which the patrol gangers do not receive. In other words, while the standards stated that scour inspections were required, Irish Rail did not provide their staff with the tools or skill set to do so. This type of thing is actually pretty common, and there could be a variety of reasons that it was not corrected. It's possible the patrol gangers weren't aware this requirement was in the standard, since it appears it was not closely monitored. It's possible that the patrol gangers knew about the requirement and that they couldn't complete the task. They raised the concern to their superiors, but nothing was done. Or it's possible that no one understood the risk of scouring and didn't think the inspection was required. I don't really know what happened here, but I do know that it takes participation from all levels to adequately implement a standard or policy. A track recording vehicle traveled over the viaduct on August 20th, the day before the collapse, and noted no defects in vertical or horizontal alignment, cross level, or twisting, which would have indicated the crossing was close to failure. Ground level inspections were recommended every 2 years and thorough inspections every 6 years. There was some conflicting requirements on when inspections were needed. Irish Rail was in the process of switching their inspection system over to a new protocol. The last bridge inspection card retrieved for the viaduct before the 2009 collapse was dated January 30th, 1998. Thorough bridge inspections were recommended to be completed every 6 years, but it appears that recommendation was not fully implemented. It's also possible that some engineers were not even familiar with the inspection requirements. The next bridge inspection was scheduled for 2011. All engineers complete a civil engineering and earthwork structures guidance notes on inspections course. The course is intended to give further knowledge of inspection procedures, describe the types of structures to be inspected, describe typical defects, and guidance on how to assign condition ratings. The course was standalone with no follow-up training, and the course didn't include any field instruction. It was also likely given to engineers at the start of their employment. I personally do training at the start of employment and then follow up a few weeks later once they've settled in and have a better understanding of procedures and systems. There's so much going on at the beginning of employment, it's impossible to retain everything. Also, they likely wouldn't have understood the importance of everything they were taught until they got into the field. As a manager, it's your job to make sure your staff are successful. Not only does it make your job easier, but it also makes you successful. There was a bridge scour inspection carried out in 2006 by a third party, Collins Engineers. Overall, they found the viaduct in fair condition, but the inspection scope did not include a report on foundations. If it had, it may have noted that the foundations were not on bedrock, but on the weir. This would have highlighted that the integrity of the weir was integral to the viaduct and that there was a high risk of scouring. The last ground level inspection of the viaduct prior to the 2009 collapse was dated October 5, 2007. The card was incomplete. Condition ratings were only provided for the handrail, nothing else. No photos were taken. No comments were made on the structure, even though the 2005 inspection card suggested a check for scour. The inspector's name was not on the card, and it was not signed off by a superior. The next recommended ground inspection was expected in October 2009, although based on record keeping from the 2007 card, I doubt the 2009 inspection record would have offered much. That said, it's important to note that the level of scouring present wouldn't have been visible from a ground level inspection. Divers were required to carry out a proper scour inspection. Even though this was known to Irish Rail, no formal approach was taken to carry out these types of inspections. Reminder that the viaduct fell between two divisions, Division 1 and Division 5. The investigation following the collapse found that the engineers responsible for carrying out these inspections each have approximately 800 inspections, 130 of those bridge inspections, to carry out each year. Assuming 250 working days per year, each engineer would have to complete 3.2 inspections per day. Even if that was possible, I doubt the inspection or report would have been thorough. Irish Rail was aware of requests for a scour and flood management plan as early as 2001, but nothing was ever produced. A 1997 inspection came to light during the investigation when a diver inspected the piers following removal of an abandoned barge. They noted the following. Scouring had started at the base of Pier 4. The rock armor grout had diminished by 80% on the west side and 70% on the east side of the viaduct, as well as that the grout was too light for the intended purpose. Undermining of concrete was present at Pier 7. There was evidence of cracking and spalling on the concrete deck. All of that said, no evidence of remedial action by Irish Rail was discovered. There was also no requirement for Irish Rail staff to upload information into their database, and there was no formal process for sharing information when someone left the division. This is often referred to as corporate memory loss. In summary, the inspection process was a mess. When internal inspections occurred, they were incomplete. When external inspections occurred, the recommendations don't appear to have been implemented. And a lot of this is due to Irish Rail not setting their staff up for success by developing policies and procedures to carry out proper inspections and share information. Over time, this led to significant scouring to go unnoticed, undermining of Pier 4 and collapse of the viaduct. The repairs took 3 months and cost roughly €4 million. Pier 4 was rebuilt with a concrete base and 20-meter steel piles. The other piers were strengthened with 15 additional piles at each pier. All stonework was repointed and reinforcing rods were used to strengthen each pier. The Railway Accident Investigation Unit provided recommendations to Irish Rail, which were then implemented. A technical manager was appointed who is responsible for developing, owning, and implementation of all technical standards. The technical manager is also responsible for verifying engineering compliance through checks to ensure that the line managers are adhering to the technical standards, completing inspections on schedule, and entering information into the infrastructure asset management system. This includes accountability for investigations of reports from members of the public. Within the infrastructure asset management system, an inspection regime was implemented for all bridge structures according to frequency as per the structural inspection standard. This will assist in scheduling of inspections as well as organizing the required resources. A coastal defense inspector was appointed to specifically review scour inspection information as well as develop and coordinate scour action plans. Irish Rail identified 105 bridge structures that were susceptible to scouring and conducted detailed surveys on each using a risk-based condition rating system. These bridges require inspections every 3 years unless emerging risks dictate more frequent inspections. A flood and scour management system was developed to deal with risk rating on structures, frequency of inspections, use of measurement sensors to provide precursor warnings, the use of visual and underwater examinations, and remedial action plans. Paper-based information and previous reports were entered into the infrastructure asset management system. The employee guidance program was revised to manage training and competency as well as include field mentorship. And the Division 1 and 5 overlap on the viaduct was removed. It was the only such overlap across Irish Rail. As per standard practice, when a track patroller is on vacation, a supervisor will assign a relief track patroller. So there you have it, the Malahide Viaduct collapse. It reminds me of the Ford Pinto in episode 5. In the case of the Pinto and the Malahide Viaduct, things happened in the way a large bureaucracy proceeds. I'm not saying it's okay the viaduct collapsed, but I'm also not surprised that it did. It's really easy for things to get lost and tied up in red tape. It seems like the larger the organization, the greater the disconnect between those making the policies and those fulfilling them. As much as the Malahide Viaduct collapse shouldn't have happened and could have been prevented, it seems to have shed light on some significant operational issues within Irish Rail, which led to a significant organizational restructure. Hopefully they remain vigilant and don't let complacency set in. Check out the podcast page, link in show notes for photos from this week's episode. If you're enjoying what you're hearing, please rate, review, and subscribe to Failurology so more people can find it. And if you want to chat with me, my Twitter handle is @Failurology, or you can email me at thefailurologypodcast@gmail.com. Thanks everyone for listening, and tune in next week to hear about Air France Flight 447, which crashed into the Atlantic in June 2009 on its way to Paris from Rio de Janeiro, Brazil. But more on that next week. Bye everyone. Talk soon.